In this video, we want to look at the normal probability distribution. And we've looked at this a little bit already from our last project, but we want to expand this a little bit more. So we've talked about the normal distribution, and we talked about our different values here across the bottom of this normal distribution, right? We would think of, we had our mean in the middle, and then we'd add and subtract 1 standard deviation, add and subtract 2 standard deviations, add and subtract 3 standard deviations like we just did on our last project. And when we talk about those, the question becomes, okay, we know that from the empirical rule that between these 2 standard deviations is 68%. We know that. And then we know 95 and all that stuff that we just did. But what happens if we end up with values that are not right on those values? What if we want to go from a value to here to a value to here? How can we find that area? And that's kind of where we want to go here today. Okay, so here's our empirical rule. We've talked about that previously, how between 1 standard deviation is 68, 2 standard deviations is 95, 3 standard deviations is 99.7. We've done a lot with that. I think we understand that now. And we talked about finding the values for various things. So all this we've talked about. But what if it's not exactly 1, 2, or 3 standard deviations? That's what we want to look at today. So first thing, in order to do this, we're going to need the green table that you got passed out with your notes. So we had the pink table before that was our binomial distribution. Now we're going to look at a green table that is our standard normal distribution. So let's talk about the standard normal distribution. The standard normal distribution is a special distribution where the mean is 0 and the standard deviation is 1. Now, this is kind of a made-up distribution. There's not many distributions that have a mean of 0, exactly 0, and a standard deviation of exactly 1. But this is going to be something we can use because it makes it standard, so we have a chart that we can combine it to help us out. So what we're going to look at is we're going to use this normal distribution table. Now, the big thing to understand about this table is if you have a z-value, let's start off with this, and let's say we have a z of 0.35. Now, if you look at your normal distribution chart and you compare the two sides, you will notice down the left-hand side of both of them is a z. On the one side of the chart, you only have negative z's. On the other side of the chart, you only have positive z's. So if this is a positive 0.35, you're going to look at the positive side. Now, I also want to notice where I drew this 0 equals 0.35. So we're using our z. From before, let me go back. From before, our standard normal, you can see 0, 1, 0, 1, 2, 3, negative 1, negative 2, negative 3. These are in the same place as these were where we added and subtracted that sigma. But now we're 0 or 1, so there's not much there. So if I look at that number line and I have 0.35, that's going to be about right there. And that is where I have the line drawn. So you can see this would be our 0, our 1, our 2, our 3, our negative 1, our negative 2, our negative 3. We are not going to write those numbers all the time, but we want to know where to put our z at 0.35. So now, what we want to find is we want to find this over here. What is the area over here? What's the probability? So kind of like our normal distribution, when we had our empirical rule, we would say, well, the area in here is 68%. Or over here, the area between these two lines was 13.5. We want to find what's the area to the left of 0.35. So if we go to our chart and you look at your chart, down the left-hand column, you will see z. You're going to go down to 0.3 on the left-hand chart. So if you look at that, you go down and you will have 0.3. You go across the top to where you have 0.05. You go across, you go down, and you will see 0.6368 on the chart. That is the area that's shaded in right there. Now, one of the important things you will notice if you look at the top of your chart on either side is it is always, always, always the area to the left. It says that back here at the beginning. It's the value to the left of the z-score, or the z. It is always to the left. You need to remember that. Always to the left. So let's look at another one. Negative 0.129. So you're going to go to your chart. You're going to go to negative 1.2. You go under 0.09, and you are going to get 0.985. So this is really like the binomial distribution. We're just kind of pulling these numbers off of our chart. Now, I want you to kind of notice you can kind of help this, help check yourself here. If we have divide this directly down the middle, you will remember for the empirical rule, right down the middle was 50% each way. So we can use this graph to kind of help us check if we're doing this correctly. Here we can see we are beyond 50%. Right? This line goes past that, so our answer should be greater than 50%, which it is. We're at 63.7. Here, this line here is 50%. We are much smaller than that, which we can see in 0.085. So this helps us to kind of just do a quick mental check. It's not going to catch all errors, but it can help us make sure we don't make a mistake. Now, it changes a little bit. It changes a little bit if we don't go to the left. Let me show you what I mean. So if I do a rough sketch, that's very rough, and I go to a value right here of, let's say, -2. So I want to find the area to the left of -2. So if I go to my chart and get -2, 0, this is 0.0228. Now, if I would go over here and I go to a +2, the area to the right of a +2 is also 0.0228 because this is symmetric and the numbers are the same both ways. So the area to the left of a -2 is the same as the area to the right of a +2. Now, if I look up a +2 in my chart, I get 0.977. And if you remember, both of these add up to 1. So if I have something where I want to find, let's say I have 1, and I want to find to the right, I really have 2 different ways I could do that. And both of these will work. One way is I could look up the area to the left of 1, and if I did that, I get 0.8413, and I could subtract that from 1. And then that would tell me my area over here is 0.1587. The other thing you can do is if you're trying to find the area greater than 1, is you could look up -1 over here, because it's symmetric and it's the same. And if I look up -1, I get the same thing, 0.1587. So two different ways of getting this 0.1587. Okay, two different ways of getting your answer. The key is looking in the table. The table is always, always, always to the left. So let's have you try one here. So we have to the right of -1.88. I will pause for a minute and you will try that however you want to do it. The two ways we just looked at, you choose the way you want to do that. What is the area to the right of -1.88? All right, so the way I did this is I looked in the chart at -1.88, and I got this over here, which is 0.0301. So this area over here is 1 minus 0.0301, which gives me 0.9699. I think that is the way that's the least confusing. You just know your chart is always to the left. That's all you have to worry about, and that will always give you the right answer. You just have to subtract from 1 if it's going to the right. Now, if you understand looking up the positive 1.88 and figuring that out, that also works. I'm not going to show that, but that works also for you. But this way always works. The next one we're going to look at is what happens if we have two values and we want the area, the probability between these two values. What we're going to do here is we're going to look up both of these values. So I'm going to look up the first one, -1.32. So -1.32, and I get 0.0934. And then I'm also going to look up the area to the left of 2.03. So 2.03 is 0.9788. Now, what we'll do, if we want to find this area here, what we can do is just subtract these two. So if you have two values, you find the two values, and you always take the bigger one minus the smaller one, and we get 0.8854. Okay? Remember, your answers always have to be positive. They always have to be less than 1. So if you're ever not sure which way to subtract, you always take the bigger one minus the smaller one. Now, a few things just to kind of hit some highlights. We already talked about this. If we find the area less than 0, if you look up 0, 0, 0 in your chart, you will see this is 0.500, just like we said, 50%. Also, I want to mention, if we look this up, between -1 and 1, our empirical rule said, I'll write it over here, that this should be 68%, right? But let's actually see what it is. If I go to the left of -1, so I look up -1 in the chart, I get 0.1587. If I look up a +1 in the chart, I get 0.8413. And if I subtract them, 0.8413 minus 0.1587, I get 0.6826. So you can see our empirical rule that we had before was just an approximation. It was rounded off. This now we can be much more exact with this value. Now, we are still working with only the standard normal. We can't work with any distribution yet. We'll get there. But we're still only working with these z's as we do these. Okay? All right. When you look at your homework and you see something like this, what's the probability z is less than negative 0.78? We want to draw a picture. Always draw a picture on these. Remember, zero's in the middle, and all we're really looking for is like, where is negative 0.78? So right here would be negative 0.78. This is z is less than that, which tells me I'm going to the left. If I have z is greater than 1.42, right? Here is 0. Here is 1.42, and I want the area to the right. The last one, if I have these two, once again, zeros in the middle. I have negative 2.02 to 1.89, and I want the area in the middle. So you can pause the video, try these three to see if you can write down your answers, and then I will come back with the answers. All right, the area to the left of negative 0.78 is 0.2177. The area to the right of 1.42 is 1 minus 0.922. So our answer is 0.0778. If we look at the area between these two, the area to the left of negative 2.02 is 0.2017. The area to the left of 1.89 is 0.9706. So if we subtract this, 0.9706 minus 0.0217, we get 0.9489. All right, so for today, it's just trying to figure out how to use this z, how to use our standard normal chart to find the area in this standard normal graph. You're now ready to try some practice problems over this.